All right, calculus review section 3 for algebra review. Long and synthetic division. We're just going to do a few examples of each. I'm going to start with this guy. This is an easy example. It's one where you wouldn't need long and synthetic division because you know that x minus 2 goes into x squared minus 7x plus 10. In fact, I can do that right here. Yeah, I'll just do it up here. X squared minus 7x plus 10 divided by x minus 2. If you got this problem, you could go, oh, I can factor the top to x minus 5 times x minus 2 over x minus 2. And then I can hack off the x minus 2's. Or just know that x minus 5 is the other term, or whatever application I'm doing with this, I can figure it out. But I know that this is going to be my answer when I divide x minus 2 into this x squared minus 7x plus 10. So, let's do it the long division way first. For the long division way, we say what times x equals x squared? Well, it's x. So x times x will be x squared. And then x times negative 2 will be negative 2x, and we're subtracting this stuff. Notice that I put parentheses around the thing that is x times x minus 2. And I wrote a minus sign here. It's really easy to mess up signs in these problems, and if you mess up a single sign, it messes up all the rest of your steps. So be really careful about when you're doing these problems to not mess up signs. So now I add them together. X squared minus x squared, 0. That was the whole point, was to line this guy up so that we got 0 there. All right, negative 7x plus 2x, because it's minus a negative 2x, is negative 5x. And then I'm going to write plus 10 by dropping this dude down here. All right, now x times what is, or x times what is negative 5x? It's negative 5. And there's my x minus 5 from up here. So negative 5 times x is negative 5x. Negative 5 times negative 2 is plus 10. Hey, look, those are exactly the same. That's good stuff. We're going to get 0, which means this went in cleanly, which means we can write the factors of this guy as x minus 2 times x minus 5. And if our starting equation was equal to 0, we're often trying to find zeros in problems like these. We could set this equal to 0, and we get x equals 2. That's what would make this 0. And x equals 5. That's what would make this 0. All right, now let's do our easy synthetic division example. We're just going to use this exact same equation. So I'm just going to use this. Okay, so synthetic, there are multiple ways to write this. The way I've seen most frequently is to do something like this. And you throw your 0 up here that you know. And so the one we knew at the beginning was that 2 was a 0. Remember, 2 is what we plug in for x to make this term 0. And that's what you need to plug in synthetic division in the corner. So it requires you to kind of understand the 0 idea. Now we're going to take the term we're dividing it into and take its coefficients and just write them down. So 1, negative 7, and 10. They need to be in order. So the x squared term here, the x term here, the number here. All right, next thing, I always just drop this first guy. Just drop it down. Then I multiply this by this, that's 2, and throw it underneath the next row, or column. Then add these together, negative 5. And then multiply this by that guy, 2, negative 10, 0. This being 0 tells us it went in cleanly. And this tells us this is now the x place, and this is the number place. So this is x minus 5. And it means our factors are x minus 2 and x minus 5. Just like up here. All right, those were all easy examples. Let's move on to some slightly more challenging examples. So I'm going to divide this. So it's going to be 9x cubed minus 19x squared, oops, minus 28x plus 12. And that's going to be divided by x minus 3. So So I'm going to say, I think x minus 3 goes into this thing. And there are going to be times in this class where I'm just going to give you this and be like, find the zeros of this thing. And this would be a really reasonable value to use. Use 3. Okay, long division way. X minus 3. Does this go into 9x cubed minus 19x squared minus 28x plus 12? All right. How many times does x go into 9x cubed? It goes in 9x squared times. If I multiply this, I get 9x cubed and minus 27x squared. I'm subtracting this, which means I'm really adding the 27x squared, so I get 8x squared minus 28x. Now I figure out what I multiply x by to get 8x squared. It's 8x. So 8x squared. 8x times negative 3 is minus 24x, which means I'm really adding a 24x, so it's negative 4x plus 12. And you see that I multiply x by negative 4 to get that, and so I get minus 4, negative 4x plus 12, and surprise, they're exactly the same. This went in cleanly. All right, we did it. So we found one of the zeros. One of the zeros in this problem, if I rewrite it, x plus 3, or whoops, x minus 3, times 9x squared plus 8x minus 4. So one of our zeros in this problem we know would be 3 now. We'd be like, okay, if this equals 0, x equals 3 is a 0. And this helps us find critical points or extrema, which is something we do in chapter 2 and also in chapter 3. So this is quite useful for that. And this is the long division way. Now let's look at the synthetic division way to do the exact same problem. So just like before, I'm going to take my actual 0 here, which is that x equals 3. So there's a little step of creativity involved here, where you're like, or intuition, where you have to go, I understand how this works. This is the 0. 3 is the thing that I'm dividing in. So 3 goes up in my corner. I write out all the factors, 9, negative 19, negative 28, 12. Then I do my line below. I drop down my first term, and I'm ready to roll. 3 times 9 is 27. Add those together, get 8. 3 times 8, 24. Add those together, negative 4. And negative 4 times 3 is negative 12. Add those together, 0. And so I get that I have 9x squared plus 8x minus 4. Which, surprise, the same as this. So, pretty cool. Also, if you notice, do some sleuthing here to show that these are basically the same method. Notice here we added 27x. Oh, 27x, or x squared. Oh, 27, 27. In this step, when we multiplied through, we got a plus 24x. Oh. And here, when we multiplied through, we got our negative 12, which is this guy right here. So all this stuff shows up. These show up here. These guys show up at the steps, what your is inside the negative parentheses stuff every time, that second term. And yeah, this is it for synthetic. Again, multiple ways of doing the same thing, often very useful. So now we're going to look at an example of one that doesn't go in cleanly. So let's do r squared plus 14r plus 38 over r plus 8. Okay. You have to make a decision whether or not you want to use long or synthetic. For this case, it's probably worth it to review synthetic a little more, so I'll do that. Negative 8 is our root, because it's what makes this bottom term 0, the term we're dividing. So then I put my coefficients over here, 1, 14, 38. Draw my line, drop down my 1. If you're curious where the 1 comes from, it's 1r squared. That's why I'm writing 1 there. All right, 1 times negative 8 is negative 8. Sweet. Add those together, 6. 6 times negative 8 is negative 48. So I got a negative 10. Every other time I've done this, in the 2 examples on the other side of the sheet, I got 0 as the last term, which means it went in cleanly. It means that if this thing was equal, if we were trying to factor this into this and like cross out a hole or something like that, this doesn't go in cleanly. However, if we're in chapter 5 of our book and we're trying to integrate something like this, it turns out it's way easier to have it as the terms that are remaining when we do this. So let's write those terms. So this is our x's and this is our numbers. The x place kind of shifts this way as you do the synthetic division because we're dividing by an x. So we have x plus 6 minus 10 over our starting term. And I realize I wrote x when I meant r because the problem has r's in it. So my bottom was r plus 8. That's what I divided into stuff. And now this is the term I have. So this is exactly numerically equal to the thing I started with. No integration or anything like that. Just these are exactly the same. This is a way of rewriting it. But as it turns out, this is way easier to perform calculus on. Like way easier. Especially in the integral direction. And so this is definitely a worthwhile task for many of the things we do in this class. And that's it.